All right, so we are going to finish up our work on centers. So we've talked about circumcenter, we've talked about orthocenter. Next, we're going to talk about incenter and centroids. Okay. Now, a median. So a median is a segment joining at the midpoint. I'm sorry, I had that backwards. Midpoint's down here. Joining at a vertex to a midpoint. There we go. So, vertex, midpoint. Now, what that means is we bisect the opposite side. Now, when three medians intersect, they intersect at a point called the centroid. Now, this is where it gets a little fun. So, usually our center, such as orthocenter and circumcenter, is equidistant to either the vertices or to the sides. So remember, if it's circumcenter, it's equidistant to the vertices. If it's orthocenter, it's equidistant to the sides. Centroids have a ratio type relationship. Okay, so first we're going to list all three medians. A little bit. So here's our first median here, BF. All right, our second median we'll say is AE. Really doesn't matter what order you put these in. All right, third one, CD. So those are the three medians. Now the name of the centroid is just point P. Now here is the special type of properties that exist with centroids. Okay. Let's look at, let's say AE here. So looking at AE. Okay. AP is equal to 1/2 PE. I'm sorry, not 1/2, 2 times. It's the other way around. PE is equal to 1/2 AP. Right. So what, just practice run, if PE was 5, what would AP be?
2.5? What? You said? I thought it was.
PE.
I thought it was half.
It's the other way. PE is half of AP, which AP is 2 times PE.
So 10?
Yeah. All right. So if AP is 18, if AP was 18, what would PE be? Again, if you have the small one going to the big one, you double it. If you have the big one going to the small one, you half it. Now, let's put this in terms of X. If PE is X, what is AP?
3 times Y?
2 times X. Yeah, 2X. So, if P is X, AP is 2 times X. What would AE equal then? 3X. Now, does that mean that PE and AP have a relationship with AE? And yes. First, PE is 1/3 AE, and AP is 2/3 AE. And we can get that just by taking the fraction, all right? x, the ratio 3x to x, okay, that is 1 to 3, basically.
Is that T or E?
Let me go with an E, because I don't see any T's up here.
How's AG one also AE is?
AE isn't 1/3. PE is 1/3 of AE. Because if PE is x and AE is 3x, what's 1/3 of 3x? X, yeah. So this will probably be the more challenging one to remember. Okay. So let's practice this. We are given that RL, the entire length, RL is 21. Okay. Now, if I want RS, what I can do is divide that by 3, because RS is 1/3 of RL. So RS is 1/3 of 21, which means I divide it by 3. RS is 7. Now, SL is twice RS. So SL is 2 times 7, 14.
Wait, how do you know that RS is 1/3 of RL?
The shortest segment is 1/3 the whole median. So this little short segment here is 1/3 of the entire thing.
So it'd be like, okay.
So if you have the entire thing, you can always divide it by 3. Now, if you have the shortest side, you can always multiply that by 3 to get the whole thing, and then multiply by 2 to get the other side. Now, we are given also that SQ is 4. So again, we have the shortest side. We can multiply that by 2 to get the longer segment. So this is 8, which means NQ would be 8 plus 4, which is 12. So we have 8, 12, RS was 7, and 14. Yes.
I thought they would all be equal distance.
Nope, none of these are equidistant.
No. That doesn't make sense.
No, just none of them are equidistant. Not a one. Centroid has nothing to, the only thing centroid will do is it'll bisect the sides. So these sides are congruent, these sides are congruent, and these sides are congruent. That is the only thing that happens with centroids. Right? Nothing is equidistant. Unless it's an isosceles or equal hour triangle. All right. So WZ is 7. That is the shorter segment, right? What do I do with that 7 to get the longer segment? Times it by 2, which means ZK is 14. Now, if I add WZ and ZK together, what do I get? 21. Now, this is obviously not drawn to scale, so don't question why this whole segment here is 8.1. Just assume that's what it's meant to be, 8.1. All right. Now, that means the smaller segment, if I have the whole thing, the smallest segment is 8.1 divided by 3, which is 2.7. And if we double that, we get 5.4. Again, if it helps, we can put this in terms of algebra, where every time you see one of these, this is going to be x, 2x. Okay, if you want to do different variable, y, 2y, z, 2z. Right? The smallest is always one variable, Larger side is always 2 variable. Add them together, you get 3x, 3y, 3z. So they just, oh, this one has nothing to do with that, does it? This one's different. This one's actually easier. They tell us that JK here, this entire segment is 22, but because these are medians, all these segments are broken into congruent parts. So what is JM and MK if it's broken into 2 equal halves?
11.
Yeah, these are both 11. So JM and MK are both 11. They give us that KN is 13, which means NL is 13, and KL 26. And then OL is 18, which means JO is 18, which means JL is 36. I don't think we need the last one, but it's there anyway. Almost done. H is a centroid. And DF in this whole segment here, is 50. Just based on that, what do I know?
Just playing. Oh, playing music and it's really distracting.
Sorry, I can't do it. So, if DF is 50, what do we know?
FD is 25.
D is 25, and EF is 25. If we know that CF, now this is the median here, so this is that X, 2X. So if CF, which is again 3X, is 42, what is X? So what's 42 divided by 3?
14.
X equals 14, which means CH is 14. And then since FH is twice that, 28. 28 and CH 14. We are given that BH is 22, which again, this is, we'll say Y and 2Y. So 22 is 2Y. What is Y? 11. So HE is 11, which makes the entire segment 22 plus 11, 33. Yeah. All right. So here's where we put some variables in here. Let's go ahead and solve for C first. What do we know about those two? Which means we set them equal to each other. So 6C minus 7 equals 4C plus 3. Subtract 4C. 2C minus 7 equals 3. Add 7 over. So C is 5. Yeah. We want to solve for x. This right here is the 3x minus 2. What is that segment equal to? What actually is the value of the segment? Besides 3x plus 2, what is that segment equal to?
The 7.
It's equal to 5. Where does that come from? Well, remember, if we have the longest segment, That is always twice the shortest segment. So since this is 10, half of that would be 5. So 3x minus 2 is equal to 5. Add 2, 3x equals 7.
Wouldn't it be plus 2?
Oh, it should be plus 2, yeah. Helps if I actually read the question correctly. So minus 2, that makes it a whole lot better. So 3x equals 3, which means x is 1.
What? Oh, it's plus.
It's plus. I wrote minus. All right. Now, y is actually a bit easier. Because here we have y, and here we have 7. So remember, the longer segment in here is equal to how much of the shorter? So what's 2 times 7? 14. No real work for that.
Wait, why don't we let the third slope?
Hmm?
Why do we do the third? So why would we like 3 times 3?
Want the entire segment?
Oh.
Yeah. Because again, 2x plus x would be 3x. Yeah. Now again, we have the shorter segment, which is equal to half the longer segment. So that means that 5w is equal to 1/2 of 30, 15. By the way, could you have just doubled 5w and set 10w equal to 30? Would that have been fine? Yeah, that'd been fine. So divide by 5. Either way, you get w is 3. All right. Altitudes. Now, an altitude is a segment joining a vertex. So a lot of these start from a vertex. That is perpendicular to the opposite side. Now, the altitude is the only shape that will not be within the triangle. So, here we have an altitude, perpendicular. Here we have an altitude. That case it's outside the triangle. And sometimes the altitude is even the leg itself. Anytime you have right triangles, well, the leg itself is an altitude.
Why is it outside the shape?
Because it has to be perpendicular to the opposite side, so it's straight down. Doesn't matter where it is, it's just straight down. It could be inside, outside, or even the side itself. You kind of technically would extend that out to see that it's perpendicular to that line. Okay. So now when the 3 altitudes intersect, okay, this is called an orthocenter. Altitudes intersect. Now, there is no relationship with orthocenter. Okay, it's just basically you have a bunch of right triangles. If you need to solve for something, you're going to do Pythagorean theorem. That's it. That's the only thing you can do. Nothing is congruent. Nothing is equal. Nothing has a ratio. Just a bunch of right triangles. So list the altitudes. Again, here they are. We have AE.
Go backwards, so you're gonna have to flip it.
DF, and CD. The orthocenter is point P. All right.
Point B.
I don't know. We just like that point P. So that is it for the notes today. There's really nothing you're going to do with. The only thing you're really going to be doing with orthocenter, besides again Pythagorean theorem, is identifying that it's an orthocenter. Okay. That's it. So tomorrow we will go over the things we did not do at the very beginning. So we're going to go back up here, start talking about mid-segment, bisectors, all these things right here. Okay, we're going to fill out this page. Okay, and we're going to practice name that center. That is what we're going to do tomorrow.
Students. Thank you. I just said what's wrong. Oh. Someone's been slow. Just like where's the thought? Yeah, I'm sure. Oh,
I didn't take a roll. Get English.
sorry about like really confusing this. So I figured out this card. How do I do this?
So if they're angle bisectors, right? So if you know you have one big triangle as well. So this angle is 44. This angle is 62. What's this angle? And then divide it by 2 to get x.
Okay, wait. Is this no wait.
Kind of do that in every single one, but here then they had you solve for the centers of line.
Jack, did you go? Do you finish already? Oh, would you for 4? So I finished my first. Yeah.
Mr. Nace, for this one, so to find x, you find the midpoint, which is 3.5, right?
Or you can double that to get 7.
So I can just do 2x equals 6.
Well, 4x minus 12 equals 7.
And then say.
Oh, I doubled that side because this side is double, so I would have to double this side equals 7.
Yeah, you can do that. That might be easier. You're still going to have a decimal.
So
Okay, like beats?
yeah, but like I thought it says beats like cashier. No. What are the what are the benefits? Because I want to get some because like I just can't. There's so much silence in the classroom. You're talking. Miss Rich over here.
Whoa.
Getting your Wait, do you have yours with you?
Yeah.
Can I try one too? And tell me if like I would look good during
We're
class.
always way behind. Not so long. Wait, you're cute with
You look bad. They feel
love it
bad.
though.
It's okay. I'm just doing this. Do I look like or should I be?
Like you should those.
I
You think
think
those
those kind of stupid on. They look good on you though.
You can't even see yourself.
They do.
Yeah, you can't see.
Oh, okay. Well, or wait, what's wrong with beats? Like don't hurt my ears though. Beats like press.
Yeah, I don't know.
Beats like can I have a?
Yeah.
Should I get? I'm with you.
After
Did you buy these or who bought mine? Here's oil.
ask women.
Huh? But like, are they hard to keep up? I feel like they're not hard to keep up. I like AirPods.
What's that?
Like AirPods. That's why when
I know what earpods are, but we can keep up.
I don't know. I lost my AirPods Pro. I've had mine for like 2 years. Like, it's more responsible. I'm like,
It doesn't.
I don't dollars. Good job.
That's so different. Let's get a job together.
Yeah, where should we? Okay.
Let's think somewhere.
No, see, somewhere like not like
Not like outdoor.
yeah, like something you just like. Kaylee has a job at like it's like this street on Main Street. It's like a I'm not sure. Hey,
This.
it's cute.
It says BE, but there's no B.
Oh, that's probably
Right here.
Wait, what?
no. It's probably
Here.
to this.
Yeah.
I'll take that. And why?
You can wear anything. You don't have the uniform like the ugly Walmart uniform.
Okay, let's think of actual. Wait, not for our dad boutique. I'm not getting that much.
They don't?
No.
No, my summer job, I love my summer job.
Why don't you do so? It's too much paperwork and work.
No, it's not.
What do you think
It-
pay
it's
is for
like
this one?
1
There's no
month to
K.
ever do
And
that.
I really don't want to like sit up there. I'm so now. I'm going to be watching for a kid's truck.
Yeah, I've done that so many times.
I need to do ever same.
You
I say it like
but
Like I feel like I'm the same size as a kid.
oh yeah. But like you're gonna have like your
Like, what if,
red thing.
Some grown adult is drowning.
Yeah.
I cannot save them.
That's where like you have to do like the 2 long whistles and then like people will come. Oh, and help.
And I just like, oh, I really don't
It's
wanna
so fun.
sleep.
Okay. You know that. I love saving people like
Not like
I love
just scared
talking.
to see-
and you're so big and it's just so fun. I don't know.
Okay. Over the summer I babysit. Then I make good money. Just make it like the same as you. So
Promise you, what was
Let me help
one of your pay? Well, one of my paychecks every 2 weeks. I think I made $1,000 in 2 weeks.
Oh, I almost never.
But that was like, yeah, that was like working a double shift every day from.
Okay.
That's good. Is that good?
what?
Working 11 to 7
Oh,
every day for 2 weeks, getting 1,000.
8 hours, 2 weeks. That is what's getting much?
40 times
Yeah, it's 40 hours a week. So how much money?
1,000.
So take 1,000 divided by 80. Now I'm assuming you just work 5 days a week, right?
I don't know, like every day.
So that means
Oh well, that's 12.5. So
it's even worse, actually.
wait,
Because if it's every day, like that's 7 days a week.
maybe not every day. Maybe like 6 days out of the week.
So that would be 48 times 2, 7, 9, 6. So 1,000 divided by 96 is that's less than what most people pay minimum wage.
Okay, something's not right.
Are you?
But like my
Are they just taking out taxes? Then that's probably why.
oh okay.
Oh, like you working for a business?
Yeah, I was a lifeguard and one of my paychecks were 1,000, but it was like for like 2 weeks straight. I was working like 8 hours. So
Then yeah, you
even that much.
yeah, most of it's probably taken up by taxes. What? Are you done? I haven't put in the system, so you'll come back to me tomorrow.
How long? Wait, the whole day? The whole day? I mean, not even the whole day. That's like the school day.
I don't know. That's how much they were paying me.
125 from 8 to 5. Were you even watching them? Like, what type of kids were they?
My cousins.
What type of kids were like? What? How old were they?
They're like 4 and up.
Oh,
And then this summer, I'm taking more, getting paid more because I'm watching like other kids too, and I'm gonna work like more.
I just want a job.
Where are you gonna work?
Babysitting.
Oh,
I'm a nanny.
I didn't hear you.
You're good.
Yes, I can. All they eat is Nutella sandwiches.
Oh my gosh, yes. The kids at babysit, they'll take like
They
a
don't eat
big
any
spatula and just scoop out all the
I
Nutella and just
know.
lick on it. It's disgusting. Then I'll put it back in there and do it.
Ew.
It's gross. They're
You
so
let them do that? You let them eat dirty?
I don't even watch. I don't even like that. I don't really like.
Okay, so that's what I'm gonna go over summer, but like I need a job now. Which
I know I need like an over Christmas job.
my parents don't want this.
Why? You don't do anything.
Oh, I guess it's because I'm thinking about playing sports. Should
Why would you
I do track?
So why would you ever do that? No, she can get that. If you train,
workout.
yeah.
I'm pretty fast. Swear I'm pretty.
The only fast girls do hurdles. Because not a lot of girls do hurdles. Like two.
I can't jump very high.
Oh my god. So many people ate crap for hurdles last year.
Yeah, no. I cannot jump over that thing. Always
Do
doing sprints.
100 meters.
Meters. That's not
Yes,
like
there's
a
some
lot.
Where?
History.
But
That's true.
history.
One side of the crowd. 0 lap.
Yeah, no.
It's like one.
Thank you.
Okay,
Yeah.
I'll do that.
Yeah.
Is that
You have to get it. You have to run the whole thing in like 10 seconds.
Oh.
I want to see you do that.
Hey, wait,
Run 100 in 10 seconds. We run.
I watched you guys like stand around half an hour.
No, we did not stand around half the time. We ran 300s, 400s, 600s, 800s,
1,000.
1,000s.
Is it?
It's 400.
What is it? I see love.
And it was huge. Let me see.
Wait, is it this one?
Oh, yeah. Do you know the correct? You look tough. Like, wait, extend them more. Yeah.
You just, like not real though.
You look like it.
No, they actually like fit well. I can hear myself. I can hear myself. Like, yeah, like the speakers, so I can hear myself. I swear.
A speaker so you can do yourself.
No, listen now. So that you're in a studio. Listen,
A studio. Have you ever been in a studio?
listen. You can hear yourself. Come on.
Wait, say it.
You can hear yourself.
That's weird. Okay, wait.
It sounds like a studio, right?
Wait, I wish I could do
No.
the next
Yeah. Don't you want? It's fine. Okay.
Like,
I did.
it's like,
It's pause. Unpause. That's so weird.
Did you do it?
Yeah, that's a big over.
like, no. You're like,
Alright. Wait, Chloe. Show me how
You-
Chloe.
What?
I'm just talking. Show me your syphilis.
What?
Show me your syphilis semester.
I'll be getting shit. There's no.
DJ.
I am the.
Like, shut up. Shut up.
Yeah, I stole it from my aunt.
I
Wait,
hate
sandwich? I know, I hate
What?
the Holocaust. That's what that's about? I haven't paid attention. Oh wait,
you still
I haven't done the third one yet, so I only got the first two.
you're German?
Yeah.
Speak something.
I'm German.
I'm not like.
No, you.
Yes, I am. My last name is German.
Rover.
Raver.
Musical sounds German.
It's this.
I haven't put it in here yet, so that's
Huh?
why.
Rover. Like.
Musical.
My last name is German too.
What's your last name? Oh,
It's like we don't
Actually,
do that every day.
It's German is pronounced Nies.
Ease?
Yeah, they pronounce the second letter first. Or the second letter makes the long
I
pause.
can't. Oh, I'm German too.
No, no. You're just showing like.
true too.
Holland is German.
German.
How are you gonna tell me what's German?
I'm German because I know my ancestors.
I do too. And German.
Dude, who's the
Oh, just the hell are you trying to say?
No, they're actually black Germans.
Yes, there's black Germans. African.
I'm sure they're.
And I'm related to them.
Uh,
Where's white Africans? You guys only
They're
grow up.
all the White House. They're usually from South Africa though.
Why though? Oh,
For plush.
it's like white African. If you're born in Africa, are you African?
There are South Africans
No.
that are.
If you're born, if you're
but
born,
if
if
you
you're
are
born in
China, you're Chinese.
I will let you know, South Africa was populated by the British,
No.
yeah,
where
It's like
they come from.
Like
I had a British accent when I was
if
6.
parents are white, she just grew up in Africa because her parents moved.
Most people who are white from Africa call themselves South Africans.
Oh,
I had a teacher that was South African.
Oh,
She had a British accent too.
maybe I'm fine.
oh, we switch.
And geometry. Huh?
Okay, we'll give each other. Okay, first hour I won't see you. I'll be in art. Actually, I might be able to see you in art. Who is Miss Watkins? I have Squire though right now.
I've never heard of this one.
Yeah, who do you have? Okay,
I'm gonna take art.
second hour we won't see each other. Biology.
where did she go?
Wait for me at the stairs. Wait for me at the stairs.
No.
Erotic discovery. Biology go upstairs and I'll walk you there because biology go upstairs. Child development, I won't see you. Oh, I'll wait for you at the stairs.
Check
That's how we're gonna jump in.
Yeah.
Why would we go over people?
Honors file, some slides.
Dude.
It's just having the day, isn't it?
Yes. No, but it's just this class. I swear, ever since Unit 6, I've been having the worst fun in math.
That's the thing.
Gotcha.
No.
Thank you. I'm gonna stop today's homework.
House enter design. Why are you designing house?
It's not you design it inside wrong, but I don't want to say it.
Yeah, just ask me to change that. Sounds trash.
Yeah, I thought intro to business was gonna be like actual, like, it's just definitely.
Well, I've never taken it with a CT board.
Hey, what should I take instead of how to
I'm taking foods. Like, I feel like I should take
not
something.
taking because that teacher to me and
Like, have you done
else,
like,
like,
about that?
Should I take a gym class? Should I do that?
Yeah, just fun. You need to go outside. It's like that.
Yeah, I'm breathing cold. I think it's really funny.
I don't take gym. It's so boring and they actually make you participate. Shut up. Okay.
That really bad.
Yeah, I need to. Right.
Can I go to the restroom, Mr. Nate?
As soon as the other person gets back.
Who?
I don't know, but that's
Right now, I have it all year round. I have my same schedule all year round.
Wait, was it Jaden? Was it Jeanette?
she took.
My gosh, she's not coming back.
Jaden came back from a different teacher.
I know. Anyway, and there's two H.
I was with Tyler all year round. No,
Wait.
no, I actually doesn't care. No, and then he found out, and then he found out, like last.
How do I know what GL and PL is on this?
Yeah, you know that.
I'm gonna pee my pants.
Well, don't do that in my classroom. You're out first. Was that?
GL and PL.
There's what? Oh,
There's no connect.
yeah, I know. I think they meant Q.
Show me, bro. Realistically close.
Dang, it's 12.
What number is that?
10.
Number 10. All right, number 10, there is no K. Okay, I'm pretty sure it meant to say WQ.
Yeah.
Okay, so number 10, I'm pretty sure it meant to say WQ.
You have to clean it and put it back on.
Oh, it gives you that GP is 8. It
Alright.
kind of gives you that GP is 8. I think it's a little arrow kind of drawn to it.
Oh, okay. I didn't know what that was. GP.
Right?
Concealer.
Is that like?
Well, like, I don't have stuff on my.
Yeah.
Okay, look.
8
Look.
divided by 2 is 4. So that means it's 4.
Okay, look. You asked me to show you.
I've never seen her in my entire life.
This number.
Yeah, I'm not gonna lie.
Who even is that?
It's a really dumb.
Wait, did he even go here?
Yeah.
Yeah.
I tried to imagine Paris.
wallpaper when I saw
There. I know Farrah.
People as a reaction.
There's some people on. It's fine.
16. Smaller.
Wait, what is that?
2x equal to 7. 2x equals 7. Yeah. 6. That's good.
Pictures into the stage of Washington.
She actually got a full ride.
Wait,
Julie,
this is showing up for like.
what's 7 divided by 2?
All right, you can go. Do you have my pass?
Oh my gosh.
Okay, there's it.
I asked her, she was like, if she started this season,
Yeah.
because you can trend. I have.
So this boy.
It's giving.
I'll try this in.
I don't think we talked about it. I don't know how to do these problems.
Oh, there.
Have you done cheating
No.
with my mom?
I didn't know.
Of course.
Oh, why are my friends slow?
I thought
you were gonna say
why? I feel like wow. Totally. Are you gonna come over here? I've been trying to talk to you.
Yeah. I'm cleaning the neighbor lights.
Why?
Regards to say, yeah.
Come over here.
Come back up to it because I'm.
giving.
I really like red.
Why? So
Come back.
every time I see you.
Finished.
Okay, I don't have 3 set up yet, so it's gonna be a bit. I'll get it in a bit.
I haven't watched
Chloe, talk about out of the window.
Oh my God. Literally nothing. You guys talk about. I love you, Judge. There's no reason. You guys are back here talking about.
You put your beach on.
You want to go sit
You like turn it on. Look, you're like a studio. Yeah.
well, like I said,
You one more that zero.
We're doing that one.
I think it's your first period teacher.
You probably that probably. Hey.
why not so really out of red?
So what?
You want to play?
Wait, here, here.
Maybe.
I do that.
She asked him.
I just know. I know.
Okay,
Hey,
well,
Mr. Nash, you want to give me the paycheck for blackjack?
No.
Sure.
Yeah.
Why not?
So-
No.
I said now, check.
Oh my god.
Yeah. You're not gonna find a lot of math teachers gambling.
Okay, problem. That was next Thursday.
yeah, make me.
There's actually everybody gave sports tennis.
Oh.
I don't want to sounds like oh, where I was in. I feel Daily if we have a week Oh,
Sneeze.
well,
Nurse's office right there. Okay. Bye.
very nice.
Well,
Is it me? When you
It's Anna.
Wait.
Anna.
5'9".
uh,
Not like they go like
Yeah, but after you. This.
it will give me no.
You need some to eat.
Like I was giving me dopamine to keep doing this. And then lose track of time for past 8 hours. And then I forget to eat the drink.
Put it away.
And then I just got I was still halfway in the
What?
car, and I just like.
Yeah.
That's what you said.
Walker from the flower.
Okay. One triangle.
Didn't change from the point 13 one and oh god. I was like, okay. It didn't go half inside, all it so full set.
Ava fish.
Yeah.
6.3 to 6.8 plus.
Yeah.
It's the correct.
Right. And then 6.7 inequalities in two triangles.
I am. Now you guys are worried. It's not walking. It's really not stuff.
Yep.
Texting.
My wife.
Sense.
Yeah, she sent me some things I need to print out.
Oh, she.
Huh?
They didn't print.
Heat sheets.
You choose.
Heat sheets.
What's that?
Swim. Yeah.
Oh, well, that makes sense. How about you, Dan?
Okay. I'll try not to lose it. Yeah.
You good? I really need that test.
On my birthday card. Accent. Giggle out loud.
I didn't realize he was here yesterday, so I saw that. I'm like, I hope she doesn't read them now.
Oh, Journey. Yeah.
All the attention stop is the
Nice better.
I finally better network. Oh, well, just you didn't get it. You know, well, I stopped this. No, look at me. This is no garden. I have 5, 11, 1, 5, 9. That's it. That's it. So it's your close. Yeah. Close to the means. Yeah. Smacking out. Do you can put all the seeds warm sort of dogs?
He's actually. Really?
Yeah. What's the
Who are you? What have you done for real college?
so much training? To the line of that. Which the back.
Yes.
Time you have to be your own. Oh, well, now you have to be sitting. I said, what? I said, what up here? Remember, you can never say. Oh, that's so then. I really make it good. I'll be good back. The bar time. You got TV. Hey, you have to. Oh, I have to. Well, yeah, I got. Come on. Oh, the movies open. Smiling. No, one. It's probably not. Well, not really. He's my face, my name. How did I went from a 9.7 I really think that was the job.
Yeah. I don't know. Or so she likes that.
All right.
Oh, like this.
You ready to talk about centroids?
Oh,
Yeah.
yeah.
Oh.
All right. What's an orthocenter, circumcenter, incenter, and centroid?
No idea.
Yeah.
What are you talking? Did they make that up for that class?
Get that up for that. You took geometry, right?
Yeah, but we had Miss Edwards.
Oh, yeah. I know.
Yeah.
Yeah, I know what that means.
Almost the. It's number 34. Yeah, does that show it's over? Because that's so why. Hawaii. I'm not sure.
You had Miss Martin?
Right.
Oh, I miss Miss Martin. Mhm.
We're learning that.
Yes,
Video from.
I will. Yeah. All right. So today we are going to discuss kind of the last topic that we are going to continue to discuss tomorrow, which again, today and tomorrow are your last lessons for this semester.
I think you feel so happy.
Does it? Then you're because then the exams are coming. It's nothing about that.
Fine, like, hey, about.
Oh, okay.
This is my only class lower than a 98. We want to.
Yeah, but
That's it's really bad.
What's the lowest? I think 98 Ohio and every class but this, and this is an 85.
That's pretty good though.
What's that difference? Only class I have. So this class, oh, we could I was wrong this time, by the way.
All right. So we are going to talk about disk method revolving around the x or y axis. So we are going to be finding the volume of a solid that is formed by revolving around an axis. So first we are going to graph the bounds of the solid. So we're going to sketch y equals x squared. Okay. And y equals 0. And x equals 2. All right. So that is just step 1. So go ahead and graph that. Step 2 is to revolve that around the x-axis. So let's look at what that means to revolve something around the x-axis. Oh. So there we go. There's our function that we have created. So what we're going to do is we are going to, and let me kind of turn this a bit so we can see this, I think. We're going to revolve that around the axis. Yeah. So revolve that around the x-axis. Okay.
That's impacting. It's this one minus. This is like useless. Dude, you pull it.
So, all right. Let's see here.
You pulled over this.
So how do we represent that on a two-dimensional sheet of paper? Well, we are going to first mirror this below the x-axis. See if I can do that a little better.
Oh boy.
Okay. We're going to kind of draw like a little oval here.
Straight line.
Oh, okay. Just move on it. So now what we're doing is we are revolving around the x-axis. So we are revolving around the x-axis.
What?
Okay. What does the area of the cross section look like? So we are going to take just like one straight little section of this. What do you think that's going to look like? A circle. One thing that may help with that answer is that the next question is what's the area of a circle? So yeah, it's a circle. Now what is the area of a circle? Pi r squared. Now, what is the radius of this circle?
Where's the circle at?
I wish it's going to mess with me, so yeah. It always does that. I'm not a big fan of this little thing. What's this one? Yeah, it does form a circle. All right. So, what is the area of that circle? Or what is the radius of that circle?
What you call it? Three.
It's not an actual number.
Not an actual number.
It's not an actual number.
E. It's E. I. The height. I. X squared.
Just f of x, which in this case is what? X squared. Right here.
What I said.
Now, generally, we use r of x to represent a radius function. Okay. Does it make a difference? Really? No. Okay. So in this case, it is x squared. Now, what is the area of one cross section? Well, since area is pi r squared and my r squared is x squared, there it is. That is the area of one cross section. Since my radius is x squared and area is pi r squared, replace r with x squared, we get pi x squared squared. Now, if you want to write that as pi x to the fourth, you can. Now, the volume of this solid. Now, to find the volume, we would take every little circle that is created using that function and add them up. Which means kind of like Riemann sums, right? And what do we do instead of Riemann sums? Integration. Now, my bounds for my x goes from 0 to 2. Pi, again, we already said x to the fourth dx. That gives me pi over 5, x to the fifth from 0 to 2, which is 32 pi over 5. Your answers on this are generally going to be in terms of pi. You're not going to want to use a calculator because this will most likely be on the non-calculator section of your test. So definitely practice your homework without a calculator. Yes?
Where do we find that f of x is x squared? What? Zero.
Beginning. They give you the function beginning. So this happens to be x squared for this function. We could have used any other function, and we will. We'll use other functions.
What if there's like two functions in that?
That is something we do later on. Yeah.
We don't have to worry about that.
Right now. That is what we're about tomorrow. Yes. Now, the nice thing is we are rotating around an x-axis, right? What if we rotate around the y-axis? If we rotate around the y-axis, we need everything in terms of y. That's really about it. But could we also rotate around something else other than an axis? No, we won't rotate around a point or any weird things, okay? We do have to rotate around solid, lines. Now, when we rotate around lines, they are going to either be vertical or horizontal. We're not going to rotate around other functions themselves. Yeah. So our formula that we are going to use is pi, the integral from a to b of pi, times the radius function squared dx, where again r of x is the distance between the axis of revolution, which in this case is the x or y axis. Okay. Again, for this one lesson, half of the day's lesson, x or y axis. All right. So take a region bounded by The region bounded by e to the x, y equals 0, x equals 0, x equals 3. Now, they are giving us our bounds, okay, because we do only have one function we're dealing with. So because we only have one function, they have to give us the bounds so we know what to integrate to. Okay, so we are going to integrate my x values from 0 to 3. That tells us right there. Integrate from 0 to 3. Okay. Now, if you remember the graph of an exponential function, okay, here we have crosses at 0, 1. We have 1, 2, 3. So we are rotating this little section here around. So we are also going to have not a great little rotation, but hey, it's there. So that's what we're going to rotate around. Right. My function is e to the x, so that is pi e to the x squared dx. Now, what is e to the x squared? Yep, e to the 2x dx. Now, if I had to find the derivative of e to the 2x, what would I have to do? Chain rule. Which means if I want to do the integration, what do I have to do? Use substitution. So again, anytime you have to do chain rule to do the derivative, you need to do u substitution.
Wait, I wish I knew that one. I wish I knew that one. Yeah.
I only said that in class. Just reminding you guys. All right, so du over 2 equals dx. Now again, because I use u substitution, I'm going to have my new bounds. All right, so when x is 0, u is equal to 2 times 0, which is 0. When x is 3, u is equal to 2 times 3, which is 6. So from 0 to 6, pi e to the u du over 2. Now I can write that as pi over 2, integral from 0 to 6 of e to the u du. Which is pi over 2 e to the 6 minus e to the 0, or pi over 2 e to the 6 minus 1. Oh my God. Thing about this question is what it actually asks for. It just asks us to set the integral. It does not say solve it or find the volume. It just says set up the integral to find the volume, but it doesn't say find the volume. The last one did say find the volume. So here we have a function that is 4 minus 2x. So 1, 2, 3, 4, going down 2 over 1. All right. Now we are going to rotate this around the y-axis. So it's going to go over here. And it's going to rotate around, forming a cone. So if you really wanted to use the formula for a cone to solve this, you could. Now, are we going to do that? No. Now, notice that this is revolving around the y-axis. Like I said before, if it's revolving around the y-axis, my functions need to be in terms of y. So if y is equal to 4 minus 2x, subtract 4, y minus 4 equals negative 2x. X equals negative 1/2 y plus 2. Now, this one did not give me my specific bounds for y, but if I look at the graph, I can see what they are. They are what? 0 and 4. Pi times negative 1/2 y plus 2 squared dy. That's all they wanted. Not good. All right. So now that we've mastered this material, yeah.
So like you need a different adjective.
Okay. Conquered the material. There we go. All right. So recall the formula for volume of a circle is pi times the radius function squared dx. Well, that we use when we are revolving around the x or y axis. Now, we're still going to do that here, use this formula, but it's going to change a bit. Okay, so let's show you what we mean by when it changes a bit. We're going to graph our function y equals 3 minus x squared. So starting at 1, 2, 3, down 1 over 1, over 1, 2, 2. So nice little parabola here. All right. We are going to rotate around the line y equals 2. And that's also one of my bounds, y equals 2. Right, so right here and right here, I do need to know what those values are. We can kind of tell what those values are, but just in case, you set these two equal to each other. 3 minus x squared equals 2. Subtract 3, negative x squared equals negative 1, or x squared equals 1, which means x equals plus or minus 1. So those are going to be my bounds, negative 1 to positive 1. Now, I'm going to bring this up, and this will apply. This may help a bit. If I wanted to find the area between y equals 3 minus x squared and y equals 2, you would take the integral from negative 1 to 1 of what? Oh, the area between. Remember the area between? We just did this. Wait, did we do this?
Well, not in this.
Yeah, not like personally together, but you watched the videos, right? Okay. So I assume I'm going to just have to move with that assumption. All right. So you find the area by taking the function furthest from the x-axis, right? So which one's further from the x-axis? Yeah, the 3 minus x squared. Okay. And you would subtract the function that's closest to the x-axis, which in this case is the 2. All right, dx. This right here is your radius. That same concept is going to apply. Okay? It is always going to be what function is furthest from the x-axis minus the function that's closest to the x-axis. Okay? Now that's true x or y-axis. So my radius is going to be pi times 3 minus x minus 2 squared dx. Now, if you read the directions, which I suggest everybody do, it says set the integral up but do not evaluate. So the only thing we can do left is to simplify this into the integral from -1 to 1. We can put the pi outside of 1 minus x squared dx. Squared, thank you. Yes, it should be.
Oh.
I didn't even draw the rotation, did I? So this is our rotation, this little football shape thing that we're going to rotate around. Number 2 is pretty much the exact same question as number 1. The only difference is we're revolving around a vertical line instead of a horizontal line. So if we had to graph this, x is equal to 2 minus y, so starting at 2 over here, going that direction, and revolving around this line here. All right. So again, it's kind of the exact same question because it's the exact same shape that we are revolving around. Okay. So here my y values, I'm going to integrate from -1 to 1 of my pi. Now, yeah. Again, you can find the bounds by doing what? Taking 2 minus y squared equal to 1, the two functions they give us. So subtract 2, -y squared equals -1, or y squared equals 1, which means y equals plus or minus 1. Like I said, it's exact same question as the previous one. Okay, it's just revolving around a vertical line instead of a horizontal line. So we have y instead of x. Now, here, which function is furthest from the y-axis? Y squared, and then the closer one is the -1. And again, you can simplify this to -1, putting the pi out here, up to, well, not 2, 1 minus y squared dy. And it is. Now, we're going to make this a little bit interesting. You guys remember the graph of exponential functions, right? Yeah. So, what do you know about the graph of this exponential function? It has nothing to do with anything I've taught in calculus. It's something you learned in Algebra 2 or pre-cal.
What was the question?
What do you know about this equation of this exponential function? That's it. It has a horizontal asymptote, right? What's the horizontal asymptote? -3. The constant for every exponential function is the horizontal asymptote. So, we have 1, 2, 3. So we do have a horizontal asymptote here. All right. You don't really have to draw that out. It just shows you we're going to get close to it. We're going to go up like that. And I'm going to get rid of that horizontal asymptote. It's going to kind of get in the way. So my bounds is I'm going to revolve around y equals -2. So I'm going to revolve around this line here. My bounds go from 0 to 1, 2, 3. So I'm going to rotate this line. So it's going to look. The axis? No, well, again, the rotation will, but the function won't. All right. Now, in this case, this one's a little different. We already said the bounds are 0 to 3 pi. In this case, what's furthest from the x-axis? Is it the function or the line of rotation? So that one's going to go first. It's always what's furthest from the axis, well, -2, minus what's closest to the axis, 2x minus 2 to the power of x minus 3 squared dx. So again, it's always what's furthest from the x-axis, or whatever axis you're looking at, minus what's closer to the x-axis. So we can simplify this. I'm just going to jump way down here. 0 to 3, put the pi outside. Since that's minus 2x, a negative 2x, well, let's leave that as 1 minus 2 power of x squared dx. All right. Do you want to know another way to do this? You kind of do. I think it's easier. All right. Is it easier to rotate around an axis? So could we just shift the function to rotate around the axis? Yeah. So for example, let's go back up to this first one here. If I wanted to shift this to rotate around the axis, what would I do to the function? How far would I shift down? So I need to go down 2. So down 2, down 2. Now all that would happen is that I would decrease this by 2, right? So my function would be 1 minus x squared, which would be my radius function, right? Well, what did we have as the radius function? 1 minus x squared. Yeah. If I wanted to shift this to the left one, so down 1, I would subtract 1 from that 2. I get x equals 1 minus y squared. And guess what my radius function is? 1 minus y squared. So you can just shift the function onto an axis. But notice that both of these functions, you're shifting from above the axis. What happens when you shift from below the axis? You do add. So we're going to add what? How much is this? 2. So we get y is equal to 2x minus 1. Is that my radius function? It's backwards, right? It is backwards, isn't it? Why does that not matter? Because it's being squared. So you can write this as pi integral from 0 to 3 of 2x minus 1 squared dx. These are equivalent. And just to remind you why this is equivalent, if I had, let's say, 3 minus 10 squared, and I had 10 minus 3 squared, what do they both give you? 49. They both give you positive 49 because you're squaring. So that's why these are equivalent. So if, on the homework, you want to shift the function onto an axis, you can do that. Okay, I personally find that a lot easier to deal with because I don't have to worry about what subtraction goes first. Okay, that is entirely up to you. If you liked how we did it, you understood how we did it because it made that connection between finding area between two curves or two lines, great. But if you can see that shift and make that, do that shift, I would use it. Okay, but that's it for the notes. So, 2 more lessons. 1 more day.
Don't love me.